Drift velocity. In conductors, the electrons are in random motion and they make collisions. An electron will suffer collision with the heavy fixed ions, but after collision it will emerge with the same speed but in the random directions. If we consider all the electrons, their average velocity will be 0 since their directions are random. Mathematically, we write u1, u2, u3, etc. un be the initial velocities of these free electrons, and we know the average velocity u average is equal to u1 plus u2 plus u3 plus etc. plus un whole divided by n. And these free electrons are in random motion, hence their average velocity will be 0. Now let us see what happens if the same conductor is connected to an electric source, so that an electric field E act between the two ends of the conductor. When these free electrons come under external electric field, they deflect with force F, which is equal to charge of the electron into electric field. If E, small e is the charge of the electron, capital E is the electric field, then F is equal to E into E. Let this be equation number 1. According to Newton's law of motion, if m is the mass of each electron, due to the influence of the external electric field E, the electrons are accelerated through A, so that v is the velocity after a time t. In such case, F is equal to ma according to Newton's law of force, equating RHS EE equal to ma. So what is acceleration? Acceleration is equal to EE divided by m. We'll call this equation number 3. Now let us calculate what is the average velocity after the application of electric field. Once the electric field is applied, all these free electrons are having velocities in the same direction. They are all aligned and drift in the same direction. Let v be the final velocity and u be the initial velocity. A is the acceleration happened in time t. According to the equation of motion, v equal to u plus at. For the individual electrons, we write the equation as v1 equal to u1 plus at1, v2 equal to u2 plus at2, v3 equal to u3 plus at3, etc. For the nth electron, Vn equal to Un plus Atn. And what is the average velocity? If V average is the average velocity, which is equal to V1 plus V2 plus V3 plus etc. plus Vn whole divided by n. Substituting V average equal to V1 U1 plus AT1 plus V2 U2 plus AT2 plus U3 plus AT3 plus etc. plus Un plus Atn whole divided by n. So if we rearrange, this will be U1 plus U2 plus U3 plus etc. plus Un whole divided by n plus A into T1 plus T2 plus T3 plus etc. plus Tn whole divided by n. We know U1 plus U2 plus U3 plus Un divided by n is the average velocity U average. Already we know U average equal to 0. That is the velocity, average velocity of these electrons when no field was applied. This is equal to 0 plus A into Tn, or we write this is the average of all these T's, T average. And this T average we write as tau. T average we write as tau, which is the relaxation time or average relaxation time, average time taken between successive collisions. And this V average we write with symbol Bd, where Bd is the drift velocity, Bd equal to A into tau. And what is A? A we got as A E by M. Substituting Vd equal to E by M into tau, which is the expression for drift velocity of the electrons under the influence of external field. So when an electric field is applied across the ends of the conductor, free electrons drift with velocity Vd equal to E tau by M. And due to this drift, the electrons are aligned in a particular directions and causes current flow through the conductor. Thank you.